Leetcode 57, insert interval. It's a medium type problem, and it's similar to every interval related problem, and it's like a whole class of those problems on Leetcode, which all of them or almost all of them are medium problems which require a couple steps. Yeah, so you either have to sort or you have to reorder them in some way, and basically there is no deep knowledge of any algorithms or algorithm strategies like greedy algorithms or dynamic programming. It's not needed at all. You just need to have your standard programming toolkit and understand what are pairs, what are lists of pairs, and how to construct conditions using ifs. Yeah, that's more or less what are those problems about. So they are medium because usually they require more than one step, so they are not the easiest ones, but definitely nothing especially hard. You should be lucky if you get such an question in an actual interview. And here is the description. You are given an array of non-overlapping intervals called intervals, where intervals on index I is like pair, where first element is called start and second element is called end. Yeah, and also there is a condition where the first element is always smaller than the second element. Represent the start and the end of the ith interval. Int intervals is sorted in an ascending order by start. Yep. And here they specify that it's already sorted. Yeah, so usually when they don't specify, it means that there will be test cases which are unsorted and you have to sort yourself. Yeah, and this is usually the first step. But in this case, they have added this additional constraint that is already sorted in an ascending order by the first element of the pair. Yeah, so it's already given. We don't have to do any sorting, but you are also given an interval called new interval. We have a second input, a single pair. Yeah, we have if you take a look on the right side, we have a first input called intervals. It's a list of ints, yeah, and those inner lists all have two elements. Those are those pairs. And the second is new interval, which is just a list of ints, which is also having can only have two elements. Yeah, so they use lists for that, but actually lists are unbounded, and for our case, those inner lists here and this list will only have two elements. Yeah, and the second new interval we have to insert, of course, because the title is insert interval, and they say it here: insert new interval into intervals such that the order will remain. That intervals is still sorted in an ascending order by start I, and interval still does not have any overlapping intervals. And this is another important thing, that the intervals theoretically can overlap, but here they specified that all of them are non-overlapping. And that means that if we have such a new interval that will overlap with some of the intervals that are already there, maybe with one, maybe with more than one. Yeah, of course, it could be long. This new interval can be long and can span multiple intervals that are already there. Then we will have to merge them. So that's the next thing. And they even specify merge overlapping intervals if necessary. And we have to return the new intervals after the insertion. Note that you don't need to modify intervals in place. Okay, you can make a new array and return it, which is usually easier when you can just create like a result data structure. You put your new stuff there, and you don't have to worry about indices and stuff like that. And so usually when you don't need to modify in place, it's easier, but not always. So it's just a rule of thumb. But in this case, we don't have to worry about it. And there's a first example. We have two intervals, one and the first pair goes from 1 to 3, then from 6 to 9, and the new interval that we have to insert goes from 2 to 5. Yeah, and because we have to insert it, it overlaps with this one, and they got merged. So it goes from 1 to 5 after the merge was done, or after they were merged. And the second interval was non-overlapping, so it's left the way it is in the input. And the next example has many intervals: 1 to 2, 3 to 5, 6 to 7, 8 to 10, 12 to 16. And we have new interval 4 to 8, which overlaps with many of them, overlaps with 3 to 5, 6 to 7, 8 to 10, and all of them are getting merged to this single interval 3 to 10. Yeah, so let's maybe copy this since it's more interesting problem. And let's copy this to know what we have to do. And we have new interval 4 to 8. So let's try to draw it, or you can even have an arrow for that. This. And let's put some numbers here. We'll create an x-axis, 3, 4, 5, 6, 7, up until 16, 8, so we are half, 9, and now 10, 11, 12, and 13, 14, almost there, 15, and 16. And we have to make our arrow a little bit longer. So now let's draw those intervals. So let's give them different colors. Let's say the first one is green. It goes like this from 1 to 2. That's the first interval. And then the next one will be blue. Or maybe we can draw all the input intervals as green, since there will be too many colors if we just use the different colors for all of them. This goes from 3 to 5. So it goes like this. It's a bit longer. To 5. The next one goes from 6 to 7. Like this. From 6 to 7. Make it a bit longer. Then from 8 to 10. Goes from 8 to till 10. And 12 till 16. So those are the input intervals, and of course they are sorted, and there is no overlap between them. But there comes the new interval. As you can see, it goes from 4 to 8, meaning that it interferes. It interferes with 3 intervals in total, and for the last one they just meet here in 8. But both of them touch at 8, so they are still interfering, and that's why we have to merge them. So how can we solve this type of problem using programming language of any kind? So what kind of algorithm can help us? Algorithm like this is as follows. We'll split the input interval to 3 subgroups. Split to 3 sub-intervals or something like this. Or maybe 3 containers, just like this. First one will be left, or all the intervals to the left. with no overlap. And then all the intervals to the right with no overlap. And finally, the third container are all the intervals that overlap with the new interval. And so there are only three options. We can split the input intervals into those three containers. And for the third one, we have to do an additional work. We will have to merge to single interval. Single like this. That's it. Just 4 steps and the problem is solved. Okay, so let's try to do it here in Python. We will use list complications to split them to right, left, and middle, or overlap, however we want to call it. And of course, those are all intervals for interval in intervals. If the interval, we can move it here. If the interval on if the end part of the interval, the right side of this pair is less than the start of the new interval, and then it will be to the left, and it will be to the right if this one is, if the start is bigger than the end of the new interval, and it will be in the middle, or there will be an overlap. Otherwise, so we can copy this, and now we can say if not either this or this. Or yes, and now let me just make it a bit more readable. And that. And that's it. So if it's not that or that, then it means that there is an overlap. And now we have to merge the overlap. We can also add the new interval here. And the middle will be the following. It will be the minimum out of all in the middle. The minimum for the let me do it like this. So interval 0 for interval in middle. And plus the maximum. So the smallest out of all starts and the biggest out of all ends. Interval 1. That will be the middle part, and we have to return left plus middle plus right. That's it. Let me check if I didn't make any mistake. And I have a mistake. Expected. Let me see. And I can see that there is a typo here. Sorry for that. Let me recheck. Still wrong answer. But I can see that there are different types. That's because this one needs an additional array. So this is like a single pair, and here we are merging the lists of pairs. Yeah? So we will put it in an additional list, in an additional container, and let's run again. accepted for the first 2 cases. So let's now check on all the cases, and we beat 100% of other players. That's because the list comprehensions, even though we have done them separately, it could be done even faster probably. And but we usually when you do list comprehensions, they are faster than, for example, just looping and updating some data structure in a loop. So if you can use list or dictionary comprehensions, then do them, and that will probably make your solution a bit faster.